Hello, hello. How's it going, everyone? Welcome to another Chicago Kotlin user group. Today we have Mohit Sarveiya. We're actually really excited for this one. This is a Google developer expert for both Kotlin and Android. And of course, oh, where did my slides go? There we go. All right, so if you've never been to a Chicago Kotlin user meetup, we always include the same slides. We like to be consistent. We have a couple rules. We believe in being an inclusive group. So that means you should be curious, ask questions, and always avoid assumptions. And even in pandemic, we should always find ways to continue to grow trust, empathy, and friendship. We're always looking for volunteers. It's a great way to expand your network, and we're always a safe space to practice talks. We do have an open CFP. I can definitely share it on the YouTube chat and make sure that there's access to that. If you have any talks for conferences, maybe you have like a practice talk for work, anything like that, we'd love to, please use us. We love to see brand new talks. And of course, it always looks great on a resume. So always looking for talks, please. I think I've been seeing a couple more entries in our open CFP. So if you've input any entries yourself, I'll probably be reaching out to you at one point or another very soon. Remember, you can stay connected with the Chicago Kotlin user group via Slack. Kotlin Lane Slack is really great. You should definitely join it. And we're on the Chicago channel. And of course, we do have a Twitter called Chicago Kotlin. Oh, and we do have live interactions, sort of. You know, we're using YouTube. So, of course, you're always welcome to ask questions, even during the presentation. And of course, we have Twitter, and then hey, it's Mohit. That's Mohit's Twitter handle. Sorry, switching from work to meetup sometimes can be a little bit jarring. Hey Mohit, how's it going?
Hi, I'm good. How are you?
Good. I'd like to always start with a few questions. I see that there are a few people online. Where are people hailing from? Of course, there's no pressure on any of that, but please feel free to share where you're from. I always kind of enjoy seeing that. But Mohit, where do you hail from?
I'm hailing from New Jersey.
New Jersey. Love it.
Have you been to New Jersey?
I have not. Actually, that's not true. I did work for a summer in New Jersey. I actually was supposed to live in Jersey City, and then I got scammed out of housing. So I ended up living in the Bronx for the summer. Then I commuted to New Jersey for work.
That's great. Yeah, it's a great place.
Yeah, no, I really love New Jersey. I had a great time there, both New York and New Jersey. Yeah, why don't you tell me a little bit about yourself, and we'll get started soon. And of course, we'll go through the presentation, and then I'll have a few announcements to add on to at the end.
I'm an Android engineer. I was an early adopter of Kotlin. Fortunate enough for that, I started using it back in 2015, and since then I've been helping many companies to integrate Kotlin, and since then it's been great, having to help companies to integrate Kotlin. I also, started using coroutines early on, and I also, do some backend development in Kotlin. I also help out with that on backend, and yeah, that's technical. And from a technical perspective, my background. Besides that, I'm just a person who lives in New Jersey.
I mean, that's pretty impressive. I think I've been using Kotlin since 2017. So it's very commendable to find people that have been using Kotlin, you know, longer than 2017. So definitely an early adopter. So that's very exciting. Yeah, I don't know if you'd like to add anything else. I know like we have this presentation underway. If you want, we could get started.
Oh, yeah. So Micronaut is something that my presentation is on Micronaut, which is a backend framework just like Spring. And I use it for my own projects. So, and I like it very much. And yeah, that's what I'll share in the next few minutes.
Great. Cool. So let's whenever I think about Micronauts, I always think of that one game. So yeah, really looking forward to the presentation. You know, we'll get set up in a few seconds. I'm just gonna put on a song. I'm gonna assist with putting on the StreamYard. Just give us a few minutes and we'll get underway. Okay. Mohit, would you mind adding your StreamYard to
yeah.
Yep.
So
cool.
Give me a second. So it says I'm already added to the stream.
Oh yeah. No worries. We'll figure this out in just a second. Just hang tight, everyone. Let's see. Oh.
Tennessee whiskey. Oh, that's sweet strawberry wine. There is one, the glass of brandy. Honey, I stay strong on your love all the time. Oh, that's me. Tennessee whiskey. Tennessee whiskey. Tennessee whiskey. Oh, that's me. Tennessee whiskey. Tennessee whiskey. Tennessee whiskey.
All right. Okay. Here we have it. Yeah, without further ado, we have Mohit talking about Micronauts with coroutines. I'm going to excuse myself out, but just as a note, if anyone has questions throughout the presentation, totally okay to ask in the chat. You know, I might pop in from time to time to ask if there are any pertinent questions. Like we usually encourage that for Chicago Kotlin users. So any questions at all, feel free to ask, like either during the presentation or at the end, whichever works for you. Okay, take it away.
Great. Thank you, Amanda. So my presentation is about how to use Micronaut and how to use them with coroutines. So what I'm going to talk about and share with you is examples of how to build like REST APIs, simple REST APIs with this framework. And how do you set up like database access to like some backend database? How do you do load balancing and handle retries? So these are some common things you would want to do as you're building like backend microservices. So what is Micronaut? Micronaut it's a framework very much like Spring and Grails. It was created by Graham Bros, who created the Grails framework, and he applied many of his learnings to Micronaut. It's also a polyglot implementation, so you could use different languages to create your microservice like Java, Kotlin, or Groovy. So that's Micronaut. And what differentiates Micronaut from other frameworks is that it's fast at startup, fast startups time. It has small memory footprint, and it also has so different, like, you could use meta programming, like different types of annotations to set up like retries and to set up validation. And I'll show you how that works. It's also reactive. So with Micronaut, you could basically set up controllers that return flowables. And I'll show you an example of that. And also it has ahead of time compilation. So with other frameworks, they require like reflection, and this one doesn't. It's very performant. So how do you go about creating a Micronaut project? So there are different ways, 3 different ways you could do that. IntelliJ itself has a plugin for Micronaut. There's also Micronaut itself has a website where you could configure what dependencies you need. But there's also a command line tool that allows you to create different parts of your project. And it gives you a good starting point to be able to add features. I'll show you how to use the command line tool. So in order to get the command line tool that allows you to create like controllers, beans, and clients, and you could download it using an SDK manager. And once you download it, the way you use it is, I'll show you how to use that. So first thing that we'll do is create a very simple Hello World app, and I'll show you how to do that. That basically has an API where NPI endpoint, you give it it returns a greeting. You give it a name, it returns back a greeting. So this tool, the command line tool for creating Micronaut apps, and the name is MN for Micronaut. And create app is a method, is a command in this tool. And you could give it different types of commands to create different types of apps, like a gRPC app or a messaging app, etc. And you could specify what type of language that you want to use, like Kotlin, Java, or Groovy. And you could also specify a package name that it will basically create for you. Once you run this command, it will create you this directory structure. This is very, very simple. And it has a Docker file, it has a build script with all the dependencies you need. And this is your starting point to build your microservice. So it also has an application file which basically configures starting your application. And in there, you specify, what the entry point is for your package, and you start your application. So what we want to do for our use case is build a simple API that takes in a particular name and returns you like hello, whatever the name that you gave, a greeting. So how do you create the simple endpoint? So first thing that you need to create is some component that basically reads requests and returns responses. And that component is called a controller. So we're going to execute this create controller command and give it the name of the controller that we want to create. So what that does is that it will create 2 files for you. It will create a test, a very simple test. It will create the controller itself. So for this example, what I want to show you is how to do test-driven development. How do you start from the test and then add our logic into the controller itself? So let's start with the test and look at how we could add, let's write a test first and look and write logic for it. So every test starts with this annotation at Micronaut test, and which sets up your test, sets up scaffolding for it to basically sets up your application. Great thing about Micronaut is that you could spin up an embedded server, a server that you could basically test against. And what we're going to do in our unit test is create a client. We're going to use that client to interact with this embedded server for our endpoint. So this, I'm using an annotation here at client, which I'm specifying what is the root URL for it. And in this interface, I'm going to specify that I want to perform a GET request against my service. And I'm going to give it a particular name and have it return a greeting. So what happens underneath the hood with this annotation is that it creates all the bare bones logic for you for this client. So once you do this, I need to be able to inject this client and use it in my test. So I'm going to inject it using the add inject annotation into my test. And then I'll need to use this client. So here's a simple example of a test where I want to just verify that when I call this method with Micronaut, I get a greeting back, and the greeting is greetings Micronaut. That's actually a slight typo. It should be hello Micronaut. So I want to verify that this test passes. So in order to make this test pass, I need to add logic in my controller itself to be able to handle this this name that I give to it. So let's look at how to set up your controller itself. Every controller that you set up with Micronaut starts with this annotation, which during build time, creates, it will generate a class that handles like this controller, which it will generate a class which has logic to handle routing to this controller and getting responses. So in a controller, you have different methods, and each method you specify what type of URI is it responsible for, interacting with, for sending a response back. So this is the URI that I'm going to be handling. So over here in the URI, I'm giving it the name, and in my controller, this name will be given to me as an argument to this function. If I had other segments in this URI, like name or something else, they will all map to arguments to this method. So this function here, what it does is that over here, I'm going to have it return greetings and pass back, create a string basically. This is a very simple controller. I'm basically returning a string, concatenate a string with greetings and whatever the name that you pass in. So this is a very simple logic for my controller, and this handles getting this request and then returning a response. So now when I could run this, so you could run this in localhost any way that you want in your browser, and IntelliJ also has support internally to test out endpoints via localhost. And when I run this, you'll see I specify this is the default port that it runs on, 8080. And you'll see that I'll get a response back, greetings Micronaut. So this is a very simple example of creating a hello world application. And when I run my test, you'll see it will pass. So in this so far, what we looked at is how do you set up the scaffolding for a project? How do you add the controller component in there? And how to do unit testing? So, and those are the basics. So what we want to do is add on to our knowledge and how do we use coroutines in our controller to be able to handle requests and handle responses. So coroutines is a library, a part of Kotlin, and what it is that it allows you to do asynchronous requests, asynchronous work, and it has suspending functions in order for you to do that. So it also has this construct called scopes and dispatchers and flows. And I'll show you how to use each of these things in our controller. So Micronaut, the way it works is that Micronaut, it's a library that uses reactive streams, but it has a layer on top. In order to support coroutines, it has a layer on top which interops with it. And I'll show you how this layer of coroutines layer works. So let's look at, so this is the greetings controller that we looked at from previously. It was a simple method that just returned you some string. But you may want to do some type of work where, some type of you may have some IO work that this function does, and you want to wait until that IO work is completed. And what you could do if you want to use coroutines is to make this suspending. And when you add this suspend keyword, so now this method is suspending by adding this keyword, Micronaut knows how to recognize this and how to handle this. So this method, when you call it, it will suspend itself until a response is given, and it will return it to the client. So this suspending method, how is this supported underneath the hood? So underneath the hood, what it does is that, so it uses reactive streams, so it uses things such as flowables, completable, and publishers. And what it does is that it goes and it looks at your controller and it sees that, are you using a suspending method? And if you are using the suspending method, what it will do is basically create a publisher. It will create a publisher. It will check whether this is suspended. And what it will also determine is that, is your suspending method returns some particular type or not. And based on all those checks, it sets up a completable from publisher. And if it also sets up a publisher if your function doesn't return anything. So the point of these slides is that there is logic in the layers. There's a layer on top of Micronaut. There's a logic which handles interoperability. It's a bridge basically from going from the coroutine world to what Micronaut to this reactive streams world. So the other thing that you would want to use, or word commonly used, is dispatchers, and they allow us to schedule work on different thread pools. So suppose that I wanted to be able to create a coroutine on a particular dispatcher when this method is called. And how do I do that? So what you could do is set up an executor service, inject an executor service, and then from the executor service, you could create a coroutine dispatcher. So what you could also do is that you could use different types of dispatchers. There's also there's a default dispatcher and an IO dispatcher, and you could create your own also. So the way you create a coroutine, over here, I'm creating a coroutine, and I'm specifying that I want it to run on a particular context. I want it to utilize this coroutine dispatcher that I made. And all the work inside of this Lambda block will be done on that particular dispatcher. So knowing which context to use, which dispatcher to use, could affect the performance of your application, and depending on your use case. So this is a simple example of how to use with context in your controller. Start a coroutine on a particular dispatcher. So the other thing that coroutine supports is also using scopes. So you could create coroutines using scope builders that are part of the coroutines library. So, for example, there is a coroutine scope builder it's called coroutine scope, and everything inside of here, well, this internally will create a coroutine on a particular scope, and then all the work inside of it will be done on that coroutine scope. You could also specify in here like what type of dispatcher that you want to use as part of this method, I believe. So this is how you utilize this coroutine scope function in this controller. So the other part is flows, which is the most powerful thing. Usually, so in my example, it was very simple where just return had one particular response, but you may be building an application where your controller is sending back responses at different intervals. So you have a stream of responses. And how do you model that? So with Micronaut, you can model that with coroutine flows, or you can model with RxJava, an observable. So the way you utilize the flows for this use case is that, suppose I have an example where I want to create a endpoint called /stream, and it returns you like particular items, and the server returns you particular items at different intervals. So in your controller, for my use case, I could create a method like this, and the return type is a flow of some particular response, int or whatever data class that you want to return. So Micronaut knows underneath the hood, in the bridge that it has, it understands how to handle a flow. And so one simple logic that we could add in here is that here's an example of a flow, or I'm adding numbers, a flow that emits numbers 1, 2, 3. And before each emission, it delays for a particular time. So when I run this, in IntelliJ and I test this, you'll see that the problem that I'll get is that it returns me a response that has absolutely nothing. So what I found is that because you need you need to include this library. So the coroutines library itself has a lot of has a module for testing. It has a module for this interoperability between reactive streams or RxJava versions 2.3 with coroutines, and it allows you to it has utilities to be able to go from basically observable world or a flow and a flow world, and so I need to include this in order to make my application work. And because you can see there's a bridge that sits on top of this Micronaut core layer. So when I include that, then I finally get some response, a chunked stream of values that I expected. So when you look at underneath the hood, how this works is that there's a converter. So Micronaut goes and looks at your controller, and it sees basically you're using a flow. And in order to set that up, and you'll see that right here, it's converting it to a publisher. So the library that in the coroutines library, it provides you with utilities to go from flow to publishers, and that's what it's using over here. And this is how this is the bridge basically that it has between the flows and reactive streams. And so that's interesting. So these are all the different ways, different examples of how you could use these different suspending function dispatchers, or creating coroutines, or using flows in your controller. And how Micronaut supports these different things. So we looked at how to use coroutines, how to set up a Micronaut project. Now we'll get into a little bit much more advanced topics. No, not really too advanced. These are obviously, when you're building a microservice, it's communicating with some database, and you have some form of an API to be able to grab things from the database and etc. So how do you set that up with Micronaut? What is one way to do it? Everyone has different ways to set this up, and I'll share with you an example. So suppose that we want to build a microservice, like an app that has an API for getting different tasks, basically building a to-do app. It has endpoints for listing tasks, for getting a particular task based on some ID, for being able to create a task, and also like based on some information given by the client on what the task description is, and also being able to edit a task, and lastly deleting it. So this is a very simple like to-do API that how do we create this with Micronaut? Suppose we wanted to store this information, like some particular to-do item, like in some database. So I'll share an example of this, how to do this. So one way to do it is to use something called Hibernate. And Hibernate provides you with something called an entity manager, provides you with an API to communicate with any type of database that you have. So the first thing that we need to do, if we were creating this application, is to create our data class that we're going to use for a task, and have an ID and a description, and you could add more fields to make it more complex, like for example whether it's in progress or completed, etc. So next thing we need to do is specify how we need to create a schema for this table, right? And one way to do that is to create using this entity annotation, and it will create the database. A table will be created for this. So you can see that using this annotation, I specified the name of the table, and I also have specified what will be the ID of the table. So this table will have this column, ID column, and it's going to be like its primary key, and will auto-generate every time that I add things to it. The next field will be a description. I have specified constraints, whether it's nullable, whether it's unique. So you could also use a SQLite if you like. Also, that's another alternative to use this. So what I need to do now is to build a repository that communicates with this database. So how do I build a repository to do this? So let's first start off by looking at how to implement a very simple example of getting a particular task based on an ID. So I have my task repository, and I'm going to inject this entity manager that knows how to like query the database and knows how to perform like create and insert operations. And I'm basically going to ask it to get me basically a task for some ID. And I have a method in here to be able to do that. And basically going to tell it to return basically find me a particular task, and it knows internally how to construct the SQL query for this. So you could also utilize coroutines here. I don't show that because of simplicity, but you could also utilize coroutines and do this on different suspending functions. So the next thing that we want to do is how do we add logic to be able to create a particular to-do item. And in order to do that, I have a method that takes in a description given by the client. And I create a task for that, and I just call persist on my entity manager, and it knows how to insert it into my table. But so there's another approach where suppose you're in a use case where you need to create the SQL statement yourself. And this is an example of doing that. So suppose I want to update an existing task and change its description. And I have a query here to update basically the description column and for a particular task ID. And I'm going to give that to my entity manager and basically give it the parameters that the client is giving me, and it will run an update, perform an update for me. And also, lastly, how do you set up deleting a particular to-do item? I'm just very simple. Basically, the entity manager has a remove method to handle that. So this repository knows how to interact with the database. How do I use it, lastly, in my controller? So that's what I'm going to show you next. How do you use this in your controller? So in your controller, you're basically, the client is going to give you, basically going to call these different methods. And I'm going to inject in my task repository in there. And I'm going to say that this controller, it will handle all types of requests for this task URI. And I'm going to say that this controller runs on an IO executor. So how do we handle this, getting a particular to-do item based on task ID? And basically like this, this is the simplest use case where here, just telling the task repository, find me particular task ID. So you can make this more robust and not have it return some nullable, and could handle that in different ways. So the next part is, how do you, have it create a particular to-do item? And how do you handle that in the controller? So what I'm going to do is create a data class to encapsulate what the client sends me. And I'm going to perform validation before giving it to my task repository. And in order to do that, to set up being able to validate, what I could do is that, for example, the client could give me an empty string, and I want to give it the right response to it and to validate that before going to my database. In order to set that up, you could use constraints like these. These are constraints on a particular field, like not blank, for example, or you could also, there are different types of constraints that exist that you could use. So at intercepted, what it does that tells Micronaut at build time to create logic basically to handle these for this task save command to be able to handle just checking these constraints, creating all the logic for this. So it goes in. So this is a save method. And basically, this is what I'm going to take from the save command, and I'm going to say at validate. So validate whatever this data class and its fields, and give it to my repository. After giving it to my repository, I need to be able to send back some HTTP status code. And in order to send back an OK, Micronaut has a library for that, to handle that, redirects and handling all of that. And it allows you to set custom status codes or send errors. So the way you would do that is that, suppose I want to send back the item that was created as part of the response, and I could do HTTP response.created. So lastly, when you delete from particular tasks, you may want to not send a response. And you could also do that. Suppose that the controller sends you no content, and there's a method to allow you to do that, no content method on the static method on the response. So that's an example of how you could create this very simple task-based API that communicates with the particular database. So when Hibernate, as you're starting to build this off, you could you don't have to set up your database at first. You could it will use an in-memory cache if you don't do that, and you'll see the dialect that it uses. It will use a different dialect if you set up for example some other database, and you'll see it in the logs. So in order to configure your database or anything, there is a YAML file that every Micronaut app has, and the file you could configure what the driver that you're using and what type of database you're using, etc. So if I make a post request, if I were to test out my application, so you'll see in IntelliJ that I could test it out and I'll get the right response that I was looking for each of these types of requests. So the other thing that you could do with Micronaut is that when you're developing something, you could very quickly spin up a client to be able to test your microservice. And there's a command that allows you to create a very simple one that doesn't have a lot of like logic in there. And there's a command to do that called create CLI app, in which you specify, similar to what you did as we saw before, what type of language that you want to use for it. And what it will do is that it will create like a client with with an interface, and you can specify in there that I want to test basically my like this get task method, and I could also test my any particular type of request that I want to try out, and I can inject it into this. So this creates a runnable. It's very simple. And in there, basically, you could call your client, and you could also test out like retries if you want, etc. And it's very simple for testing. So we looked at how to build basically a REST API like that communicates with the database. We looked at the Micronauts HTTP library and how to create a simple client. So those are the basics to know about using Micronaut. The last two things very quickly that I'll share are circuit breakers and load balancing. As you're building like a robust application, you want to be able to handle like, retries with backoffs. And Micronaut provides you with like an annotation, like this concept of, it's called a circuit breaker, that allows you to specify like how configure those retries. So suppose like in your controller, there was an exception and you want to do a particular number of retries with delays. And it allows you to specify an exponential backoff, like this number of attempts you want to do and the amount of delays you want to have in between those attempts. And it's, it's through an annotation, which makes it really nice. And the last thing is load balancing. As you're building an application, you basically, you want to be able to handle as many requests and be able to scale. And the strategy of load balancing that Micronaut uses is round robin and by default, but you could use a different strategy that you want. So an example of setting this up is, for example, you could set this up in the YAML file to set up how you want to do load balancing. An example of this is that you could, for example, use console, which is a service, and specify, this is just for testing that I specified the host and the port, and I specified to register with console, which serve apps that I could spin up. And you'll see that it will register with console. That's how you configure it in the YAML with Micronaut. And that's one, so it uses round robin by default. So, that's everything, all the basics of using Micronaut. It's a great framework that I've been exploring. I wrote a blog post about everything that I just shared. And you can check it out on my website, codingwithmohit.com/Micronaut with Kotlin Coroutines. And I hope that would be helpful. I'll also link out these links. There is a really great YouTube video from the creator himself on it and on decisions that he made and why he made them. On his motivations for creating Micronaut. And also I have given if you need help with using coroutines, I have given many talks and have a lot of content on it. Also want to share lastly is that I'm starting a Kotlin Coroutine training, enjoy really helping people and teaching them. If you're looking for individual sessions or if you want training for your for groups, for your company, or you could contact me for any bookings, like at my email, Kotlin Coroutines training. I could tailor a curriculum to teach you coroutines, and I could teach you how to test coroutines and things to watch out for when you test them. I have a lot of experience testing coroutines, so and how I could basically help you with using coroutines either on backend if you need help or on Android. And so I hope this presentation was useful on using Micronaut, and saying thank you to Amanda for giving me the opportunity to present at this meetup. Means a lot to me. So thank you very much. If you have any questions, just let me know in the comments, and I will answer any questions you have.
Thank you. No, thank you for giving the presentation. This was a great one. We actually do have some questions from the audience. So the first one is, Brian is definitely interested in hearing if you have any experience with a more reactive-based SQL database library like R2DBC in production.
I don't have a lot of experience with it. With database that are provide a reactive, like libraries that provide a reactive API. Yeah, so, but I'm sure there are many of them out there.
Yeah, there was some, Brian said he hadn't looked at it in over a year, but he had some concerns over reliability, robustness of that particular library, and was interested in seeing how how another library that played a lot nicer with coroutines might work out. So this was like really great stuff. I do have two more. Oh, okay. Actually, just kidding. There's another question. So do you have suggestions for best practices for wrapping coroutines with the blocking library? That's a good question. I was actually going to start following up with a couple of questions related to that as well. Maybe not with the database, but.
Right. So what you could do is one approach. Is that if you have a blocking, like you could create a flow, or you could create an API that has a flow which internally like interacts with this library, and based on when based on when it has a response or a particular response, the client could receive some response back. So using building basically a wrapper using flows, for example, is one possibility. Or you could build an API that uses a mutable flow, for example, which for example, this library, it blocks until there's some particular response that gets pushed out to this shared flow that the client is listening to. I hope that answers that question to the best of my ability.
Yeah, I think no, those are some very solid observations. I think definitely. Just as a quick note before I forget, because I always forget these things. I know you mentioned that you had a website and you also had a blog written up. Please be sure to send that to me so I can tweet that out. Yeah, I had a personal question myself. Do you ever like run into, because I know you talked about using both RX Java on top of like coroutines and flows, and I was like curious to hear like what the business use case is for using both in a single library.
Right. So the one use case is that you have some legacy code that's in RX,
Classic.
It's very useful when you have like, as you know, many people, like when they create feature, I'm sure you have used some type of teacher toggles, right? For creating features.
It's a bit
so you may have like in that scenario, you basically are forking based on some particular if you want some particular usability on, and you may be interacting with legacy code, and legacy code could be in RX, but you're building some new API, and in order to interact with it, that's one use case of utilizing those utilities. So like some people, they have an app that has a lot of RX Java, and they're slowly trying to migrate to coroutines, and that's another use case where it's really helpful. Yeah.
Okay. Let's see. Oh, I have one more question, and if there's nothing else, I do have a couple announcements at the end. So please feel free to stick around. I think they're very short announcements. But the last question: have you ever run into issues, and specifically with like subscribing and publishing restrictions when it came to working with RX Java and flows? Or did you find that flows like actually solve some of those problems that, sometimes like you'll create some kind of event dispatcher and it kind of just goes off, and sometimes it's hard to track later on?
Yeah, so I have encountered issues with that. For example, like the issues I've encountered is that, for example, you convert an observable to a flow, and then that in itself creates a coroutine, but handling like cancellation, for example, handling ANRs around that. So those are the two problems I've encountered.
Well, I know we're getting up to the time. I'm definitely interested in hearing more about that. If you should definitely expand yourself. I'm gonna just go ahead and share like the last of the slides. Thank you so much, Mohit. Really appreciate it. Thank you so much for the great talk. I really enjoyed the content.
Great, thank you. Thank you for having me.
Thank you, and take care.
You too.
Okay. All right. So the rest of you, don't go just yet. I have the last few. Grindr is hiring, so this is really exciting. Especially they're looking for senior software engineers. I actually have a couple notes because I was afraid I was going to forget. The backend stack is mostly Java 8 for now, but their app is actually one of the most trafficked Kotlin apps on Google Play. So that's like really cool, exciting stuff. They're building out a team right now, and they're hoping to kind of like base the team in Chicago, but it is a remote first job. I did post the link on here, but I will be sure to have the Chicago Kotlin account tweet out the rec for that, the link for that. So be sure to check that out. Android developers are always hard to find, but they're looking for really smart and really nice people. And I think there's one more. I think I mentioned this previously, but we do have open CFPs. We actually have an upcoming meetup. I'm going to have to double check myself. For early April, we have Eli talking about, wow, I did not write notes on that, so I'm going to have to excuse myself on that. But we do have a meetup coming up in a few weeks, not too far from now. It's Eli Burns, and he'll be talking about implementing and using backend services with gRPC and Kotlin. So it's going to be another pretty heavy topic on backend services and Kotlin and gRPC. I hope to catch you at that one. That's going to be April 8th. That's going to be on a Thursday. I know we normally do these things on Wednesdays, but we're going to be shooting for Thursday this time. Yep. So that's everything for now. Thank you guys so much for sticking around. This was a great topic. This was a great presentation. I enjoy seeing everybody on the chat, and I really love seeing all the participation and seeing where folks are from. Thank you so much, and take care. Have a great week. 今ざして恋のプログラムを